back. Mr. LaBelle's Math Show. Today is Tuesday, March 3rd, and we are going to be looking at rectangles and irregular polygons. We're going to continue our shape work, and with everything for my maths, it's very important that you complete this lesson before going on to doing the homework. We've had some children that have been doing the homework only and not the online lesson, which has resulted in some very simple errors. So we can see by the results of how many times that you attempt to do the questions and how many answers you get correct and you get incorrect, it is very clear to us who are the children that are doing the online lessons, because their results are much better than children that are skipping straight to the homework. So don't try to save yourself some time. Make sure you spend some time doing the lessons, because in the lesson, everything you need to know for the questions are in the lesson, okay? So today's lesson is on rectangles, like I said, and irregular polygons. You're going to go through this homework, and you're going to take a look at what these rectangles have in common, okay? All rectangles of different shapes and sizes have similar things in common, okay? We know that rectangles have right angles, 90 degrees in their corners. We know that this symbol here shows 90 degrees. These two perpendicular lines, we were looking at perpendicular lines already. These perpendicular lines is where the two lines cross, and that is a 90-degree angle. And we can show that using these small squares for 90 degrees, all of the rectangles have 4 90-degree right angles. Okay? We were looking at parallel. We can see that all rectangles have 2 lines that are parallel and equal to each other, of equal length, and another matching pair of parallel lines of equal length. Okay, 2 sets of parallel lines. Now, opposite sides are equal. This side is equal with this side. This side is equal with this side. Okay, and we can mark sides of the same length with short, straight lines. This is a new thing that we have not looked at yet. We can show using we looked at parallel lines with the arrows, looking at matching parallel lines. In the case of a rectangle or a shape, we use these little lines here to show that this line is the same length as this line. This length the same length as this line, and so on. Now, we use 2 lines to show that another set of sides that are of equal length, okay? So this side is of equal length to this side is of equal length to this side, and we show that with 2 small lines. Okay, now we can break down rectangles and look at their properties in a lot more detail. We can see here that this rectangle has 1, 2, 3, 4 right angles, and this length is the same as this length, marked by 1 line, and this length is the same as this length, marked by 2 lines. Okay? Now, we can go through, and you're going to read the different characteristics of this rectangle, and then it's going to ask you, what will this sum be? So since a right angle is 90 degrees, we can calculate the sum of all of the angles in the rectangle. So if we know that this is 90 degrees, and this is 90 degrees, and that's 90 degrees, and that is 90 degrees, what is the total sum of all of the rectangles? How would you find that? Okay, now, speaking of properties of rectangles, we can take a look and see, well, we know if this is 2 centimeters, and it is an equal length in parallel with this side, what would that be? And then if this is 8 centimeters, and it's of equal length to this side, what would that be? And we can tell that this angle is a right angle, so how many degrees would that be? You put in the missing sides and the missing angles in order to be able to find the answers, and then click Mark It. Now, here is another rectangle. It is 7 centimeters by 13 centimeters. if we know that's 7 centimeters, what would that length be? And if we know that is 13 centimeters, what would that length be? Okay? We could tell that this would then be 7 and this would be 13. So by knowing that these lengths are the same, we can find the missing length of each side. Okay? Now, this is a word that we've touched on a little bit, but we're going to come back to it. It's perimeter. We talked about it in my class about children being soldiers marching around the perimeter of their headquarters. So, like soldiers marching around the perimeter of a headquarters to protect it, we look at perimeter as the length all the way around the entire rectangle. And in this case, we know that this is 13 and this is 13, so 13 plus 13. This is 7 and this is 7, 7 centimeters and 7 centimeters. 13 centimeters plus 13 centimeters plus 7 centimeters plus 7 centimeters equals 40 centimeters. And that is the length all the way around. Okay, so we can actually find missing numbers. Can you tell us what the perimeter of this rectangle is? Well, this is 12 centimeters. What would that be? This is 4 centimeters. What would that be? Can you put in the missing numbers to find the total perimeter of centimeters around this rectangle? Okay, here's another go at it. We have to reverse engineer this one. So we know it tells us here that this is 42 centimeters, which is the perimeter. All the way around is 42 centimeters. Well, that's 18 centimeters. Then if that's 18 centimeters, what would that be? Okay? Now what we need to do is find the missing lengths with the information that we have. We need to use our knowledge of rectangles. Opposite sides are equal, so that tells us the answer to this one here. B must be 18 centimeters long. If this is 18 centimeters long, B must be 18 centimeters long because these are the same length. Okay, so you work through and you look at, here we go, 18, you look at the different questions to find the missing shapes. We know that all the way around the perimeter is the total combination of adding up all of the sides. And we also know that this is equal to this. Okay? So we can work out that if the perimeter is 42 centimeters long, we can work it out that A plus C plus 18 plus 18 equals 42. So how would we use these facts to help us? Well, like I said, we can reverse engineer. We can find the missing lengths of A and C together because we know that this is 18 and this is 18. We're just missing these two. And we know that these lengths are the same. But we know all the way around is 42 centimeters. So we can work it out. We can subtract the length of the known sides from the perimeter, and we will be left with the total, or the sum, of A and C. Okay, so A plus C, this is A plus C equals 42 centimeters all the way around, minus 18 centimeters, minus 18 centimeters. Okay, so that means 42 minus 18 leaves us with 6 centimeters. That means that the length of these two sides together is 6 centimeters. Now, we then remember that this length is the same as this length, and their total together is 6, so what could those lengths be? We then have to divide by two different sides, and we know the total between the two of them is 6, so this length plus this length is 6. We divide it by how many sides we have, which is 1 and 2, and we know that 6 divided by 2 equals 3 centimeters. So the length of this side is 3 centimeters, and the length of this side is 3 centimeters. Okay, so then you have a go. You have a perimeter, you have one length. Can you work out the missing sides? Okay? Now, area is the shape of the amount of space inside the shape. Perimeter is the length around the shape. The area is the amount of space inside the rectangle. And we measure area, and we put this little 2. This tells us that this number means the space inside, the area inside the rectangle. But we can then work out, oh, it's happened again. Let's hit pause for a second, guys.